guys. So the week prior to our exam, the third exam, we started the non-homogeneous second-order differential equations practice problems. But I thought we could do a little bit more of those exercises, and then we can see all different formats. So it's just 5 problems, and I will be going over all of the 5 problems in detail. Alright, so this one was find a particular solution to this equation. Okay, so alright, so we can begin. I think probably the easiest is just pretend that this is a homogeneous problem, and we can write this as r squared minus 4r minus 12 equals to 0. And we can easily get to the next stage, which can be factored out as r minus 6 times r plus 2 equals to 0. And this will give us the two r values, which is 6 and negative 2. So our complementary solution, now this is called the complementary solution, is in the case where this one side is not equal to 0. Okay? So our complementary solution, I'll call it t, this is going to be c1 e to the power of negative 2t plus c2 e to the power of positive 6t. I should have probably used a different variable other than t, because t is used here. But yeah, so just note that this t used and the t that I'm using is different. Alright, so we have the complementary solution that we can easily get from just setting our equation equal to 0. Now we need to get the particular solution. And particular solution follows this form. So let's say that this is going to be our general format, p of t y prime plus q of t equals to g of t. Then our particular solution is going to take on the form of g of t. Okay, so what that means is that our g of t right now is 3 to the power of 3 times e to the power of 5t, which is an exponential equation. So our particular solution will probably, and then I'll call this y, I have the lowercase p to stand for particular. So our particular solution will have the format of a times e to the power of 5t. Okay, and let's find out. So from here we can do y prime is going to be 5a e to the power of 5t, and also y double prime is going to be 25a times power of e to the power of 5t. Alright, now that we have these values, we can plug these into our original given equation. So we have 25a e to the power of 5t minus 4 times 5a 5t minus negative 12. Y is just going to be this value, a to 5t, and that should equal to 3e to the 5t. Alright, so we have 25 minus 20 minus 12, so this gets us to negative 7a, and so we know that no matter what the t value is, these values cannot equal to 0, so we're safe to just divide them out both sides, which gives us our a value as negative 3 over 7. Alright, so there we go. So our particular solution, which we're going to write particular solution in terms of the t, this is going to be negative 3 over 7 e to the power of 5t. So this is our answer to problem 1. All right, so for problem 2, we're using the same previous problem given, and we're just given the additional information, which are our boundary conditions. So essentially we are trying to find, we have to find the C1 and C2. Okay, so our general solution, as you have seen in the textbook, is going to follow this format of y of t is going to equal to the complementary solution plus the particular solution. So in our case, from the previous problem, we have both the complementary solution and the particular solution. So by copying those, we have C1 e to the power of negative 2t plus C2 e to the power of 6t. This was our complementary solution, and our particular solution, sorry, it should be C2. Particular solution was negative 3 over 7 e to the power of 5t. All right, so let's plug in 0 to this. So we have y of 0. This is going to give us C1 plus C2 minus 3 over 7. This is going to equal to 18 over 7. So we have C1 plus C2 equaling to 21 over 7, positive 21 over 7, which is equivalent to 3. All right, so it seems like we have to find a derivative. So let's go ahead and do that. So y prime of t, this is going to be negative 2 c1 e to the power of negative 2t plus 6 c2 e to the power of 6t minus 15 over 7 e to the power of 5t. And let's plug in 0 into this. So this gives us negative 2 c1 plus 6 c2 minus 15 over 7. This equals to negative 1 over 7. So we have negative 2 c1 plus 6 c2. This is going to equal to, well, if you add 15 over 7 both sides, we're going to get positive 14 over 7, which is positive 2. Okay, so we have these two equations, and we have two unknowns, so we can definitely find the values of C1 and C2. I'm going to multiply 2 to both sides of the first equation. So we have that, and I'm going to add these two equations together. So we have positive C1 minus C1 minus 2C1. These two gets canceled out, and I have 8C2 equals to 8. So here C2 equals to 1, and I can take the original equation and then plug in 1 to C2. So I have C1 plus 1 equals to 3. That gets me C1 as 2. All right, so plugging back in these equations or these values, I have the general equation, which is y of t. This is going to equal to 2 e to the power of negative 2t plus 1 times e to the power of 6t minus 3 over 7 e to the power of 5t. And this is the solution.